All right, hello AP Physics students, and welcome to this video lecture on projectile motion. This video lecture is going to introduce you to some principles of projectile motion, and obviously we're going to be going much deeper than what is presented in this video lecture, but this is your introduction to get you thinking about projectile motion. So first things first, what is a projectile? And the simplest answer here is that a projectile is an object upon which only the force of gravity is acting. Okay, so really simple example here. Let's say I have a building and I have a guy standing on the edge of the building. Why, I don't know. He also has a ball, and he drops the ball, and that ball, I think we can agree, if we think back to free fall, is only experiencing a force of gravity. So it has an acceleration due to gravity as a result of that force of gravity. So this object in free fall is a projectile. Now another example of a projectile, let's say that I have a person standing on the ground here and they throw a ball straight up in the air with some initial velocity. So at the top of the path, momentarily that vertical velocity is 0, and then it starts its journey straight back down. Now again, as soon as that ball leaves the person's hand down here, it is only being affected, its motion is only being affected by the force of gravity. So this ball being thrown straight up and coming straight back down is an example of a projectile. One more example, again, I'll have a guy standing on the ground here. Okay, guy standing on the ground, and he throws a ball at some angle. Okay, so he throws a ball at some angle. And then it comes back down. I'm going to run out of room here, but you get the idea. Again, as soon as this ball leaves this person's hand, it is only being affected, its motion is only being affected by the force of gravity. So again, in this scenario, when this ball is being launched at an angle, it is also considered a projectile. Okay, so a big takeaway on this slide, a projectile is an object upon which only the force of gravity is acting and affecting an object's motion. All right, so we have a couple different types of projectile motion, and the first one that I want to discuss here is horizontally launched projectiles. So to do this, I'm going to draw a picture. I'm going to have a cliff here, and on top of this cliff is going to be a cannon that is going to be pointing straight out, and it is going to shoot a cannonball out of that cannon. Now, what I want us to think about, this is a little thought experiment. I want to turn gravity off. Okay, so this cannonball that's now being shot out of the cannon is not going to be affected by gravity. So if it's not being affected by gravity, it's going to be shot out at some horizontal velocity, and that velocity is going to be constant, assuming that there's no air resistance. And again, we are going to assume that there's no air resistance. Okay, so what this is showing us is that at 1 second, we're at this distance, at 2 seconds, we're at this distance, and so on and so forth. And notice, at these different time intervals, I'm covering the same distance because we are at a constant velocity. So this is our gravity-free path. Now, let's turn gravity back on, and let's just imagine that we just dropped a cannonball from the top of the cliff. Well, what is that going to look like? So that's probably going to look something like this. Okay, as time is going on here, our cannonball, the distance between those time intervals is actually increasing. So at 1 second, at 1 second, our cannonball is here. At 2 seconds, the distance increased to here. At 3 seconds, our distance has increased. At 4 seconds, our distance has increased. And at 5 seconds, our distance has increased. So This path right here is gravity free. This path is that cannonball in free fall. But what does the path of our cannonball actually look like as a horizontally launched projectile? Well, we can figure that out by matching up these points at the different time intervals. So at 1 second, my cannonball is going to be there. At 2 seconds, my cannonball is going to be there. At 3 seconds, it's going to be here. At 4 seconds, my projectile is going to be there. And at 5 seconds, my projectile is going to be way down here. Now, what I want to do is I want to kind of connect these points. And if we do that, we're going to see that the motion of this cannonball creates a parabolic, well, half a parabolic path. Okay, that's key. So we create a parabolic path. Now we can break this down even further. And let's say that I want to look at the time intervals, or I want to look at the spacing, the distance between, the cannonball at the different time intervals. So what I'm going to do is I'm going to draw some vertical lines at those different time intervals. And you can see here that if we look, the distance between the cannonball at those different time intervals is constant because we have a constant velocity in the horizontal direction. Now let's do the same thing in the vertical direction. So I am going to draw some horizontal lines here. And if we take a look at each time interval, the spacing or the distance between that cannonball at those different time intervals is increasing because in the vertical direction we have a non-constant velocity. We're accelerating at 9.8 meters per second each second. So the distance traveled in each interval is increasing. Okay, so the big takeaway from horizontally launched projectiles is in our horizontal direction, our velocity is constant. Therefore, in each time interval, that distance covered or that distance traveled is constant. In our vertical direction, our velocity is non-constant. We have acceleration, and that acceleration is 9.8 meters per second squared. So therefore, our distance traveled in each time interval is increasing. Now, our second type of projectile motion is non-horizontally launched projectiles. And we can also call this angle-launched projectiles. So to explain this one, I'm going to draw a very similar picture as I did on the last slide. However, instead of drawing my cannon shooting straight out, I'm going to have it pointing at some angle upwards. Okay, so this is at some angle theta. Now, again, I want to turn gravity off to begin this explanation. So if we turn gravity off, that cannonball is going to have a path looking like that. It's just going to follow a straight line, okay, because gravity is not affecting it. So what's going to happen here? When we turn gravity back on, this projectile is obviously not going to follow this path, correct? So what's going to happen is that it's probably going to look something like this. Okay, so we can connect these lines again, and we can see that, again, we get a parabolic path. And that parabolic path is created because gravity is now affecting this cannonball's motion. Now, I want to take a look at each time interval again. So I'm going to draw my vertical lines to look at the time interval and the distance covered in each time interval. And if we take a look here, now this is an imperfect drawing, but if we take a look from 1 to 2 seconds, from 2 to 3 seconds, and from 3 to 4 seconds, the distance traveled in those time intervals is constant, because again, in our horizontal direction, we have constant velocity. Now, looking at the vertical direction, draw my horizontal lines. We see that from 1 to 2 seconds, from 2 to 3 seconds, and from 3 to 4 seconds, my distance traveled in those intervals is increasing. And that is because in the vertical direction, we have a non-constant velocity. We have an acceleration of 9.8 meters per second squared, because this cannonball is now only being affected by the force of gravity. So to wrap up this first video lecture on projectile motion, I want to summarize this information with a table of sorts. So what I want to take a look at is I want to take a look at horizontal motion of projectiles, and I want to take a look at the vertical motion. Because remember, in 2D kinematics, we can split things up into its components. And in projectile motion, we have horizontal motion and we have vertical motion. So we're going to split these up. Now, in horizontal motion, first thing I want to think about, are there any forces acting on the object in the horizontal direction? Our answer there is no. There are no forces acting on the object in the horizontal direction, because we're assuming that there is no air resistance. However, in the vertical direction, are there forces acting on that object? And our answer here is yes. It is the force of gravity, and it's acting in the downward direction at all times. Now, next thing I want to think about is acceleration. In our horizontal motion, think back to the horizontally launched projectile slide, the angle launched projectile slide. Did our velocity change? No, it did not. We had a constant velocity in both of those projectile motions at all times. Now in our vertical direction, we did have acceleration, because we know if the only thing acting on that object is the force of gravity, we know that we have acceleration in the vertical direction, and that acceleration is 9.8 meters per second squared. The last thing here, and this kind of goes along with acceleration, is our velocity. Well, we said in the horizontal motion that we have no acceleration, so therefore our velocity is constant. However, in the vertical motion, we said that we had acceleration. So obviously, our velocity in the vertical motion is changing. And how much is it changing by? Well, it's changing by 9.8 meters per second each second. Okay, so really this video lecture, I wanted you to be able to visualize the two types of projectile motion, understanding what's going on in terms of the velocity, what's going on in terms of the acceleration, and how that affects the path of a horizontally or angle launched projectile. So next week we're going to be delving in deeper into projectile motion, first beginning with horizontally launched projectiles, and then moving on to get a little more advanced with angle launched projectiles. Have a great weekend, AP Physics students. Take care.